The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
13 states a sphere of radius r and mass m has a rotational inertia about a diameter that is given by 2/5 mr squared. A string of length r is attached to the surface and is used to suspend the sphere from the ceiling. Its rotational inertia about the point of attachment at the ceiling is given by x mr squared, where x is blank. So, he draws a picture, and they say the sphere is of length radius r, and we have a string attached to the surface of length r as well. Now the picture is actually drawn a little confusing, so you really have to read the problem carefully to realize that this is where the string is attached to the surface. Okay, so this from here to here is actually the length of the string. Now they tell us that the rotational inertia of the sphere about its diameter, or in the center, through the center of mass, is 2/5 mr squared. Now, all the shapes that they give you the formulas for, you don't have to worry about deriving because they gave it to you, but you do have to remember that those rotational inertias are for the center of mass. So if they're asking the rotational inertia about some other point, you have to use your parallel axis theorem to figure out what that I value would be, your rotational inertia value. So, the formula to basically shift the the formula to calculate I at a location other than the center of mass, basically to shift the location for calculating I about, is I of the center of mass plus our mass times h squared, where h is going to be the distance you move it. Okay? So this is where this I value represents I about that point of rotation. We're shifting the point of rotation to the top. They tell us they ask for its rotational inertia about the point of attachment. This is the point of attachment, so we're shifting it this far, which radius of the circle from the middle to the top, and then the point of attachment is a string of length r, so we're actually shifting it 2r. That is going to be our value for h. So with that, what we can do is pretty much just plug it in. We know this. And m doesn't change, same mass. Our height is 2r. And we're going to square it. Now, don't forget, this happens a lot. Some people make mistakes with it, some don't, but you have a lot of situations where you have something, a variable that is another variable multiplied by some coefficient. You have to square both of them. Just algebraic rules, you have to do it. So don't forget, you're squaring 2r. You're not just going to put m times 2r squared. It's actually going to be m times 4 r squared. Okay? Now nothing changes over here. It's going to be our value of I. Now what happens is when we rewrite this, we can see that each term has an mr squared with multiplied by a coefficient, so we can add those up no problem. Now 2/5 is just going to be equal to 0.4, and the reason I'm doing that is because all of our answers are in decimal places, not in fractions. Just have to pay attention to the answers they give in the problem. Sometimes they use fractions, sometimes they use decimal points. There's no really rhyme or reason to it, you just got to keep track of what's going on. So we have 0.4 mr squared plus 4 mr squared, and that is going to be equal to our shifted rotational inertia value. So I is just going to be equal to 4.4 mr squared, which is our answer to the problem number 1 on your practice test. Now, this is actually not the answer to the problem, this is the rotational. What they want is they want the value of x, and they present it in such a way that they want I in the form x mr squared, which we do. We have it in the coefficient x times mr squared. but they want just x. So x is just going to be equal to 4.4, and that is actually going to be our answer. Excuse me. Make sure you finish the problem. Hopefully you would have gone through it and seen that there were no mr squared, so it wouldn't have been an issue. But just make sure you read the problem all the way through and pay attention. So x is equal to 4.4.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.